Standard 6.10, graph logarithmic functions. All right, so before we graph a log function, let's talk about what the parent graph looks like. If we were to consider the parent graph, y equals log base b of x, our parent graph looks something like the following. It has a vertical asymptote at x equals 0. And the shape of the graph looks something like this. It's basically the inverse of an exponential growth graph. So if you remember from the previous unit, exponential growth looks like this. And let's write exponential growth here. And the log graph is its inverse, which is just a reflection across this line. So you can kind of see what the graph looks like. It looks like that red graph there. Now, when we graph a logarithmic function, we want to have at least 2 points and an asymptote. So let's start with our asymptote. Our asymptote is generally at x equals 0, unless there's been some kind of translation, some kind of shift. So if we took a line on x equals 0, wonder if I can do this. No. So if we took a line at x equals 0, and we push that line up or down, it would still be at x equals 0. But if we push the line left or right, then the line moves to another x value. So only horizontal translations are going to affect the location of the asymptote. Otherwise, it'll be at x equals 0. So we look at our equation. Are there any horizontal translations? Well, this minus 1 moves it down 1. So moving a line that's a vertical line at 0 down 1 is not going to move it away from 0. It's still going to be at 0. Only if it was moved left or right would we move our asymptote. So our asymptote is still here at x equals 0. Okay, and again, that's because there's no horizontal translation, only a vertical one. Now we want to pick some points. And so let's make an xy table here. And let's think about what values might be appropriate to substitute for x in the equation y equals log base 3 of x minus 1. Now notice our base is 3. So let's pick x values so that we can evaluate at base 3. So for example, let's pick x equals 1. If we pick x equals 1, we have log base 3 of 1 minus 1. We do the log before we do the subtraction of the 1. So log base 3 of 1 is 0 because 3 to the 0 power is 1 minus 1. And that makes negative 1. So 1, negative 1 is a point on our graph. Let's pick 3. And if we pick 3, we have log base 3 of 3 minus 1. So log base 3 of 3 is 1. 1 minus 1 makes 0. So 3, 0 is another point on our graph. So again, you want to pick convenient values of x. If we picked, for example, x equals 4, you'd have log base 3 of 4 minus 1. And we can't evaluate log base 3 of 4 without a calculator. We don't know what that is. But powers of 3, like 3 or 9 or 27, those would be good values to pick for x. All right, so we know where asymptote is. We have a couple of points. We know this red graph is a general shape of a log function. So let's connect our points and get our graph. All right, let's take a look at a second example here. And in this particular example, this plus 2 shifts our graph to the left 2. So a vertical asymptote, which is normally at x equals 0, gets pushed 2 units to the left and is now at x equals negative 2. If it was a minus 2, it would move to the right 2. Left or right movement is indicated when there's a number inside the parentheses attached to the x, like this plus 2. Vertical movement is indicated when there is a number attached at the end without a parentheses, like the first example with the minus 1. All right, so our graph has horizontal translation of 2 units to the left. Our asymptote is now at x equals negative 2. All right, so we're going to take our function, and again, we're going to pick convenient values for x and make a little xy table. So let's pick We don't want to pick anything on -2 or to the left of -2. Let's pick x equals 1. So we have 1 plus 2. And we like x equals 1 because this works out to be log base 3 of 3, which we know the value of, which is 1. So 1, 1 is a point on our graph. Let's pick 7. So the reason I'm picking 7 is because then we have log base 3 of 7 plus 2, which is log base 3 of 9, which we know the value of, and it's 2. So 7, 2 is another point on our graph. If we wanted to, we could pick -1. We don't need 3 points, but let's see what happens. If we pick -1, we have log base 3 of -1 plus 2. That's log base 3 of 1, and anything to the 0 power is 1, so our power is 0. So -1, 0, that's another point on their graph. Again, we know what the shape looks like. Connect the points to get your log graph. So a couple of key things you want to remember. A log graph has a vertical asymptote. It's normally at x equals 0 unless there has been some kind of horizontal shift, a shift to the left or a shift to the right, in which case your asymptote will move in that direction. And then just pick convenient values of x so you can evaluate your function and get some points. This is standard 6.10, graphing a log function.